Our next talk is going to be given by NASA Lunar Science Institute's very own Brian Day, and he's going to be talking about the Lunar Atmosphere and Dust Environment Explorer. So, Brian.
Thank you all very much for coming out here tonight on this beautiful evening with that beautiful moon up above us. This is a really exciting time to be studying the moon. As you may have heard, NASA right now has 5 spacecraft in orbit around the moon doing science around the moon. That is a record. That is the most we have ever had, and that is some indication of how exciting the moon is. And so they are now about to be joined by another mission, our next mission to the moon, LADEE, the Lunar Atmosphere and Dust Environment Explorer. Now that name is kind of provocative. I will tell you, when I went to school I learned that the moon does not have an atmosphere. But guess what? It does. It has a very, very thin atmosphere. Here at the surface of the Earth, if you were to take a cubic centimeter of atmosphere, it would contain 10 to the 19th molecules, a whole lot of molecules. If you were to do the same on the surface of the moon, it would contain about 100,000 to a few million molecules. Now that sounds like a lot, but it's not. It's actually a very good vacuum, and as a matter of fact, it's similar to what our astronauts experience in the outermost fringes of the Earth's atmosphere when they do a spacewalk at the International Space Station. It's a very, very, very thin atmosphere at the moon, but it's not inconsequential. As a matter of fact, the moon's atmosphere absorbs energy from the sun, and it actually glows, and it glows brightly. Now, looking up at the moon, you may have never noticed the glow of the lunar atmosphere. Well, that's because it's always next to the big bright moon. But if somehow you were able to remove the moon and leave its atmosphere behind, then from a dark sky you would be able to look up and see that glow of the moon's atmosphere with your unaided eye. What's the moon's atmosphere made of? We don't know. But we want to find out. It's a very, very interesting thing. And as a matter of fact, we think that in addition to being gas in the atmosphere, there's also perhaps an active dust component. We got our first clues from this from the Surveyor missions, robotic missions that landed on the moon before the Apollo days. And as these robotic landers landed on the moon, as they'd look out toward the horizon, with the sun just below the horizon, their cameras would catch these beautiful glows showing above the horizon. Now, if the moon's sky was empty, we wouldn't expect to see a glow. We wouldn't see the sunlight reflecting off of anything. But there is something there. And people started thinking, well, maybe it's dust that's somehow rising above the surface of the moon. And we got confirmation of this later on in the Apollo missions. More evidence supporting this. On several occasions, astronauts in the command modules of the Apollo spacecraft, as they're orbiting the moon, they'd look out the window, and again, with the sun just below the horizon, they'd see these beautiful jets and streamers arching high up into the sky, even up to the altitudes at which they were in orbit. So again, people started thinking that perhaps this was dust that had been electrostatically levitated above the surface of the moon. Electrostatic levitation, that's a fancy sounding term, but you can demonstrate this at home. Take a balloon, blow it up, tie off the end, rub it against your shirt, then hold it above your little brother's head or your dog's head or someone who's got some hair, and you'll see that hair just rise up toward the balloon. That's electrostatic levitation, and we think that something similar may be happening on the moon. Very, very interesting. But why do we really care? Well, it turns out that this very thin type of atmosphere that the moon has. The technical term is a surface boundary exosphere. This really thin atmosphere that the moon has is actually an example of the most common type of atmosphere in our solar system. The moon has one. Mercury has one. The bigger asteroids. Many of the moons of the giant planets. Even some of the distant Kuiper Belt objects, the icy worlds out beyond Neptune. This is the most common type of atmosphere in our solar system, and we know very, very little about it. But we happen to have one right next door. How lucky is that? So we're going to explore it. We're going to explore it with a brand new mission, LADEE, the Lunar Atmosphere and Dust Environment Explorer. It's going to go into orbit around the moon and then drop down low and actually fly through the moon's atmosphere, sampling it, analyzing it, letting us know what its composition is, what its structure is, and how it changes over time. Now, it's important that we do this now because a lot of countries, not just the United States, but a lot of countries are planning missions to the moon. Some of them will even have astronauts. Some will be robotic. But as we have thrusters firing, and if we have astronauts exhaling and belching and whatever else they may do, all of that activity on the moon could easily overwhelm this very thin, fragile atmosphere of the moon. So if we're going to understand the moon's atmosphere, the time to do it is now before we change it. So that's why we're going to fly LADEE. LADEE is a small spacecraft, and it is being assembled right now, right here, about a 5-minute walk from where you are sitting. It has 3 scientific instruments on board as well as a technology demonstration. 2 of the scientific instruments are spectrometers, an ultraviolet and visible light spectrometer and a mass spectrometer. These will help us determine the composition of the stuff we're flying through. And then there's also a dust experiment that will help us characterize the amount of dust, the size of the dust, and any electric charge on the dust that we encounter. So here are some pictures of the assembly of the LADEE spacecraft. This is the lower module here, and if you look, you can see the actual fuel tanks there. Again, it's not a huge spacecraft, but it's a beautiful robotic spacecraft, and it's actually starting to look like a spacecraft now. This is really neat. So it's a very exciting time here at NASA Ames as we get this robotic probe ready to go to the moon. So the plan is we are going to launch next year. We're scheduled to launch in August of 2013. We're going to be the very first deep space launch from NASA's Wallops Flight Facility on Wallops Island, Virginia. Now this launch area has been in place for a long time. It's a historic launch location, many sounding rockets, a few Earth orbiting rockets and missions, but this will be the first deep space launch out of Wallops, and we are going to be the very first mission to fly on the brand new Minotaur 5 rocket. Once we get to the moon and get into our orbit, we'll then drop down into a 100-day science mission studying the lunar atmosphere. This is a picture of the launch facility at Wallops Island, and this is what our brand new rocket, the Minotaur 5, looks like. Now, it turns out that while this is going to be a very exciting scientific mission, the science isn't going to be done just by the scientists here at Ames, or at NASA, or at universities. The science is something that can be done by large numbers of people, by members of the general public. First of all, I want to point out the amateur astronomers. You may have noticed all these wonderful telescopes in the field behind us. A round of applause for the amateur astronomers here tonight. Beautiful views of the moon. Not only are they able to provide us with these beautiful views of the moon, but it turns out the types of telescopes that they have Telescopes typically in the 8 to 14-inch diameter range. You see a number of them out there tonight. These telescopes are ideal for recording the flashes of meteoroid impacts as they hit the moon. We think that meteoroid impacts may be one of the major sources for the lunar atmosphere. And so we would love to have the help of these amateur astronomers out here as the LADEE mission flies, having them recording the actual flashes of meteoroid impacts on the moon so that we can compare those to changes that our instruments on LADEE see as we are in orbit in the atmosphere. So we can correlate those impacts with changes that we see in the atmosphere. These amateur astronomers right here can be a key part of. Well, that's great if you happen to have an 8 to 14-inch telescope. But what if you don't? You can still participate, because it turns out the vast majority of the impactors on the moon are really, really small, maybe about the size of a grain of sand. And when one of those hits, the flash of light is far too small to be observed from here on Earth. But because the Earth and Moon travel together through space, they encounter these streams of debris together. And when even a small particle hits the Earth's atmosphere, it becomes very, very evident in the form of a meteor. Who here has ever seen a meteor? A lot of you out there, great. Well, it turns out when you look up in the sky and you see a meteor, the typical solid object that's causing that meteor is only about the size of a grain of sand. So with your eye, you can detect a very, very small piece of debris. So what we would love to have happen is during the course of the LADEE mission, we would love to have people going out and counting meteors. The great thing about counting meteors is you don't need a telescope, you don't need binoculars, you don't really need much in terms of equipment at all, but I do recommend a reclining lawn chair. Might as well be comfortable. But if you go out there and count and we see how the rate of meteors changes night by night, then we can make inferences as to what's happening on the moon's surface. So your meteor counts could be very helpful. And just as is the case with almost everything today, there's even an app for that. It's great. It runs on iOS and now it runs on Android too. So yahoo, we've got it on both these wonderful phones. And the beautiful thing is when you load this, it's free. Meteor Counter, it's a free app. And you can load it on your smartphone. And then you go out under the stars. And the beautiful thing is your smartphone knows what time it is, it knows where you are, and you stand out there and you just start tapping on your screen. You tap on the right for a bright meteor, left for a dim meteor, in between for an in-between meteor. There's even a microphone button so you can make a voice annotation. You can say, it was green, or it came from the west, or just wow, whatever you want. But the cool thing is as you are tapping your screen, as you see these meteors, it's recording that. It's recording where you were and what time it was. And at the end of your observing session, it sends this information directly to NASA. So you can be a part of the science of our next mission to the moon. This isn't just NASA's mission to the moon. This is all of our mission to the moon. And you can be a part of it. I'm asking you to be a part of it. Believe me, lunar exploration is fun. So again, I hope you will join us, the amateur astronomers out there and those lawn chair astronomers. Come on out and enjoy the exploration of the moon with LADEE, the Lunar Atmosphere and Dust Environment Explorer.
Thank you so much, Brian. That was just fantastic. One of the things that I want to point out is that citizen science, the involvement of people such as yourselves, is one of the signature pieces of the NASA Lunar Science Institute, and it was also one of the big interests of Dr. Baruch Blumberg, who was the distinguished scientist for a number of years for the Lunar Science Institute, and was also a Nobel laureate. And this building, actually, after he passed away last year, was named in his honor. So this is a tradition that we really want to keep up, and we really want to involve all of you. So Brian, thank you so much.